Good morning, class 12th. In today's class, we are going to study the effect of conducting slab and dielectric slab if it is inserted between two plates of a capacitor. Already we have been studied about parallel plate capacitor, and we have studied if the entire region between two plates is filled with a dielectric substance. But here we will study a dielectric medium or a conducting medium of thickness less than separation is inserted between gap. So in first case, we will take the case of a conducting slab and its thickness is less than separation between two plates. Okay, so these are plus and minus. These are two plates of a capacitor, and the separation between these two plates is small d. Now there is a conducting slab of thickness T. Obviously this T is less than D. Now it is inserted between two plates of capacitor. The electric field between two plates is E0, and it is because of vacuum or air. So it is represented by E0. Now already we have been studied what happens when a conducting slab is placed inside or in an external field. Because of electric field, free electrons will move opposite to the direction of electric field. So negative charge get accumulated on this side of the conductor or metal, and plus charge got accumulated on this side, and this flow continues till the electric field inside the conductor becomes zero. Reason is आपने एक्सटर्नली जो अप्लाई किया है दैट इज E0, और इनसाइड कंडक्टर जो डेवलप होगा दैट इज फ्रॉम पॉजिटिव टू नेगेटिव, इट इज जस्ट इन ऑपोजिट डायरेक्शन. दिस इक्वल एंड ऑपोजिट electric field makes net electric field zero. Okay, so inside the conducting slab you can see that electric field is zero. Now अगर आपसे पूछा जाए electric field कहाँ है, so we can say that electric field E0 is present only outside the conducting slab. और अगर ये आउटसाइड कंडक्टिंग स्लैब है तो कितना रीजन बचा, ये टोटल डी में से आप इस रीजन टी को तो लेस कर दें, द रिमेनिंग थिकनेस इज डी माइनस टी. सो डी माइनस टी रीजन में इलेक्ट्रिक फील्ड E0 प्रेजेंट है. सो दिस इज ऑल अबाउट इफेक्ट ऑफ कंडक्टिंग स्लैब between two plates of capacitor. Now as conductor have free electrons, hence positive and negative charge appear on two faces of conductor in such a way that electric field inside conductor becomes zero. Now electric field inside conductor becomes zero. It has been studied in electrostatics that why electric field inside a conductor is zero. और हमने ये भी स्टडी किया था the behavior of a conductor when placed in an electric field. तभी हमने ये वेरीफाई किया था that electric field inside a conductor is zero. Now we can say that electric field E0 exists over a distance d minus t only. So what is the formula for potential difference? Potential difference is electric field into separation. So electric field is, sorry, it is E0 and the separation is d minus t. So C is equal to Q upon V. Zero means just air or vacuum. Okay, so we can write it here E0. आप किसमें correction करना है? C is equal to Q upon V. Value of V is E0 d minus t. Now in vacuum permittivity is epsilon 0. So E0 is equal to sigma upon epsilon 0. Sigma here is charge density, that is charge per unit area. So it is Q upon A epsilon 0. Substitute this value here. What you are going to get? C as it is, Q as it is, Q upon A epsilon 0 d minus t. So Q to Q cancel. What left? Epsilon 0 A upon d minus t. Okay. So this is the expression for capacitance if a conducting slab of thickness T is inserted between two plates of capacitor. Now if there is no dielectric medium, means capacitance without slab. What was the expression in case of vacuum? C0 epsilon 0 A upon d. Now you can compare. Numerator epsilon 0 is same, but in denominator here the thickness is d, here the thickness is d minus t. Which one is greater? Obviously d is greater, so C0 is smaller. So here we can say that C is greater than 0. It means capacitance increases on inserting conducting slab between two plates. अगर आप एक कंडक्टिंग स्लैब को इंसर्ट करते हैं बिटवीन टू प्लेट्स ऑफ ए कैपेसिटर, ऑब्वियसली कैपेसिटेंस इंक्रीज होगा. नाउ you can find out expression if entire region is filled with a conducting slab, means पूरी thickness d में अगर हम conducting slab put कर दें, then what happens? Just put d is equal to t here, get t is equal to d here. You will find that capacitance becomes infinite, means that capacitor can store infinite number of charge. Okay. The next thing is capacitance of a capacitor with dielectric slab. तो हमने ये भी टॉपिक स्टडी किया है that when a dielectric slab is placed between two plates of capacitor or inside an electric field, what happens? Okay. So first thing is capacitance in the presence of vacuum or air is given by C0 is equal to epsilon 0 A upon D. Now this is the region of electric field between two plates, and when air is there, so electric field is E0. So this is the dielectric slab. You can see this is thickness T. Now what will happen? Dielectric polarization takes place, means this positive charge will induce negative charge on this face and negative charge will induce positive charge on this face. This is because of polarization. Now free electrons are not there, so obviously the number of electrons in this side or number of positive charge on this side, they are very small in comparison to charge present on two plates of capacitor. Okay, so ये जो प्लस और माइनस, ये प्लस एंड माइनस, ये जो चार्ज इंड्यूस हुआ है, because of that electric field developed is EP. Now you can see E0 and EP, which one is greater? Obviously E0 is greater than EP, or we can say EP is less than E0. So what will be net electric field? It cannot be 0 because E0 and EP, they are not equal. Oh, obviously they are opposite. You can see directions. They are opposite to each other, but they are not equal. So hence, what is net electric field inside dielectric slab? It is E. So value of E is E0 minus EP. E0 आपने अप्लाई किया है, EP डेवलप हुआ है, which is in opposite direction. So we have subtracted EP from E0. This is the net electric field inside dielectric slab. तो इसका मतलब ये हुआ that presence of dielectric slab always reduces electric field, and it is just because of dielectric polarization. So we can say electric field E is present in a thickness T, whereas electric field E0, it is present in remaining thickness D minus T. Here, due to dielectric polarization, induced electric field EP is produced, which is opposite to electric field E0. Okay, now EP is less than E0. So what is net electric field inside slab? It is E0 minus EP. और electric field का formula पता है, epsilon 0 has been taken as common. Sigma is the free charge density on plates of capacitor. Sigma is the polarized or induced charge density, and sigma P is smaller than sigma. So sigma is charge density on outer plate of capacitor, sigma P charge density due to polarization on dielectric slab. Now already we know that if E0 is electric field in vacuum and the dielectric constant of dielectric slab is K, then electric field inside dielectric slab E is given by E0 upon K. Very first portion में देखें F0 upon F और E0 upon E, it is equal to dielectric constant K. So using this formula you can find out value of E as E0 upon K. Okay, so we can say electric field E is present in a thickness T and electric field E0 is present in a thickness D minus T. So what is total potential difference? E0 multiplied by D minus T and E multiplied by T. Substitute the value of E here. the value of E is E0 by K. So you can take E0 common, what left? D minus T plus, take E0 common, T upon K. So it is T upon K. Okay. Now what is E0? It is sigma upon epsilon 0, and sigma is Q upon A. So you can say V is equal to Q upon A epsilon 0 D minus T plus T upon K. Okay. Here C is equal to Q upon V. So C is equal to Q upon, what is the value of V? Q upon A epsilon 0 D minus T plus T upon K. यहाँ पर ध्यान रखें K इस पूरी वैल्यू पर नहीं है, K is divided just under T. So capacitance is equal to epsilon 0 A D minus T enclosed in a bracket plus T upon K. So this is the expression for capacitance when a dielectric slab of thickness T is inserted between two plates. Now again you can see that capacitance is greater than capacitance when there is no medium or vacuum. Okay. So these are two topics, the effect of dielectric slab and effect of conducting slab on capacitance. यहाँ पर ध्यान रखें entire region नहीं है, सिर्फ एक particular thickness T को insert किया है. अगर आप entire region को fill करते हैं then value of T must be equal to D. आप T को D के equal put कर दें. Okay. Now next is dielectric strength. Now अभी आपने डाइलेक्ट्रिक पोलराइजेशन स्टडी किया, तो अगर हम इलेक्ट्रिक फील्ड को इंक्रीज करते जाएं तो क्या होगा? आउटर मोस्ट ऑर्बिट के जो इलेक्ट्रॉन्स हैं जो लूजली बाउंड हैं, दे गेट डिटैच्ड. सो व्हेन ए डाइलेक्ट्रिक मीडियम इज प्लेस्ड इन ए वेरी हाई इलेक्ट्रिक फील्ड, द आउटर इलेक्ट्रॉन्स गेट डिटैच्ड फ्रॉम देयर पेरेंट एटम्स. और अगर ये आउटर इलेक्ट्रॉन डिटैच हो जाएंगे then that substance will behave as a conductor, because detach होने का मतलब न्यूक्लियस की बाउंडेशन से फ्री होना है, and when electrons are free they will conduct. So dielectric then behave as conductor. This phenomena is known as dielectric breakdown. और जिस particular value of electric field पर ये होगा, that value of electric field is known as dielectric strength. So what is dielectric strength? Dielectric strength of a dielectric is defined as maximum value of electric field or potential gradient, क्योंकि electric field potential gradient के equal होता है, that can be applied to dielectric without its dielectric breakdown. तो just जिस limit पर breakdown होता है उस limit से just पहले जो भी value of electric field है, that is known as dielectric strength. अगर आपको given है that this is the dielectric strength of electric field, it means above this value of electric field the dielectric will lose its property of insulation or as an insulator, and it will start conducting. Okay. Unit of dielectric strength is kilovolt per meter per millimeter. Kilovolt per millimeter, because a very high potential difference is required, or we can say very strong electric field is required to pull the bounded electrons from a dielectric. Okay. So it is always measured in kilovolt per millimeter. Now there are two topics, और ये इस चैप्टर के लास्ट टॉपिक्स हैं. हम डाइलेक्ट्रिक स्लैब को इंसर्ट करेंगे, बट वी विल कंसिडर टू केसेस. We will insert the dielectric slab when battery is disconnected from the capacitor, and second when battery remain connected with the capacitor. So first case is a dielectric slab of dielectric constant K is inserted between plates of a capacitor after battery is disconnected. मतलब आपने कैपेसिटर को पहले चार्ज कर लिया है, now अब आप बैटरी को डिस्कनेक्ट कर देंगे and then you will insert the dielectric slab. Okay. Now for very first thing आपको समझना चाहिए कि डाइलेक्ट्रिक का रोल क्या है. The role of dielectric is to reduce electric field, और अगर इलेक्ट्रिक फील्ड रिड्यूस होगा तो ऑब्वियसली पोटेंशियल डिफरेंस भी रिड्यूस होगा. ओके. और कैपेसिटेंस का फॉर्मूला पता है, कैपेसिटेंस इज Q अपॉन V. अगर पोटेंशियल डिफरेंस रिड्यूस होगा तो कैपेसिटी इंक्रीज होगी. द वेरी फर्स्ट थिंग इज द इफेक्ट ऑन चार्ज स्टोर्ड. As it is not connected with the battery, तो जितना चार्ज डाइलेक्ट्रिक स्लैब को इंसर्ट करने से पहले है, the same amount will retain or remain on the capacitor even after the dielectric slab is inserted, so charge remains same. Q dash is equal to Q. Second thing, the effect on electric field and potential. So electric field get reduced. हम entire region के केस में ले रहे हैं, पूरे गैप को आपने डाइलेक्ट्रिक से फिल किया है, then electric field is equal to E0 by K. अगर एक पर्टिकुलर थिकनेस लेते हैं तो फिर आपको अलग कैलकुलेट करना पड़ेगा, and that will be E0 d minus T plus T upon K. Potential difference get reduced. V dash is equal to V0 upon K. What about capacitance? Capacitance get increased, क्योंकि पोटेंशियल अगर डिक्रीज होगा तो आपको कैपेसिटेंस का फॉर्मूला पता है, C is equal to Q upon V. पोटेंशियल डिफरेंस अगर डिक्रीज होगा तो कैपेसिटेंस क्या होगा, इंक्रीज होगा. तो C dash is equal to K times C0. इनिशियल वैल्यू का ये K टाइम्स हो जाता है. What is the effect on energy stored? Now, what is new energy? Energy is equal to half QV. Now, the value of Q is same, तो आपने Q लिख दिया. What about potential? Potential is V0 by K. The new potential difference is V0 by K. Initial value का 1 upon K times. 1 upon K को आप common लें, then it is half of Q into V0. Half Q V0 is the initial value. So you can say the new value of energy is U0 by K. It means energy reduce होगी. Energy get reduced. तो आप यहाँ लिख लें energy get reduced. Next case is when we insert a dielectric slab of dielectric constant K when battery remain connected. बैटरी रिमेन कनेक्टेड, तो सबसे पहले तो देखें डाइलेक्ट्रिक का रोल क्या है. रोल वही है, ये इलेक्ट्रिक फील्ड को रिड्यूस करेगा, पोटेंशियल को रिड्यूस करेगा. ना यहाँ तक बात तो सही है. पोटेंशियल रिड्यूस हो जाएगा बट इट इज कनेक्टेड विद द बैटरी. तो कैपेसिटर के अक्रॉस अगर पोटेंशियल रिड्यूस होगा, बैटरी सेम पोटेंशियल पर है, तो क्या होगा, पोटेंशियल को मेंटेन करने के लिए बैटरी से एडिशनल चार्ज सप्लाई होगा, एंड दिस प्रोसेस कंटिन्यूज जब तक कि कैपेसिटर वापस अपने सेम पोटेंशियल को एक्वायर ना कर ले. सो वी कैन से चार्ज स्टोर्ड पर क्या इफेक्ट होगा, दैट एडिशनल चार्ज विल सप्लाई फ्रॉम बैटरी टू मेंटेन पोटेंशियल डिफरेंस टू द इनिशियल वैल्यू, हेंस चार्ज स्टोर्ड ऑन कैपेसिटर इंक्रीजेस. पोटेंशियल आपने देखा था 1 upon K टाइम्स हो गया था, तो उसको वापस K से मल्टीप्लाई करने के लिए चार्ज क्या होगा, द वैल्यू ऑफ चार्ज बिकम्स K टाइम्स Q. क्योंकि डाइलेक्ट्रिक ने पोटेंशियल को रिड्यूस कर दिया है, तो वापस उसी लेवल तक मेंटेन करने के लिए इट इज कंपलसरी टू सप्लाई सम चार्ज. अगर बैटरी डिस्कनेक्टेड है तो ऑब्वियसली चार्ज कैन नॉट बी सप्लाइड, बट हियर बैटरी इज कनेक्टेड, सो एडिशनल चार्ज विल सप्लाई फ्रॉम बैटरी एंड द न्यू चार्ज विल बी K टाइम्स द इनिशियल वैल्यू. हाँ, चार्ज इंक्रीज हो गया है तो पोटेंशियल लेवल भी मेंटेन हो जाएगा, और पोटेंशियल लेवल सेम होगा तो इलेक्ट्रिक फील्ड भी इनिशियल वैल्यू को एक्वायर करेगा. सो इलेक्ट्रिक फील्ड एंड पोटेंशियल डिफरेंस रिमेन सेम ड्यू टू एडिशनल सप्लाई ऑफ चार्जेस. सो V dash is equal to V0, E dash is equal to E0. कैपेसिटेंस गेट इंक्रीज्ड. चार्ज इंक्रीज हो गया है तो कैपेसिटेंस भी इंक्रीज होगा, बिकॉज C is equal to Q upon V. नाउ V is सेम, Q K टाइम्स हो गया है तो कैपेसिटेंस भी इनिशियल वैल्यू का K टाइम्स हो जाएगा. What is the effect on potential energy? Now, potential energy के लिए फॉर्मूला है 1 upon 2 CV square. आप कोई सा भी फॉर्मूला अप्लाई कर सकते हैं. Now, potential is same, so there is no effect on potential. What is the effect on capacitance? Capacitance has been become K times, so it is K times C0 and V0 square. You can take K common, so it is 1 upon 2 C0 V0 square. This is the initial potential energy, so new potential energy is K times U0, so potential energy has been increased. So this is the effect, potential energy get increased. This is the effect on different parameters when a dielectric slab is inserted between two plates of a capacitor when battery remain connected or battery is disconnected. So this is the completion of this chapter. Now it is requested that you must first note down all the formula involved in this chapter, then we will take the numerical portion. Have a good day.